plus 6, 7 is about solving rational equations. Okay, excuse me, I better do it this way. Much better. Now, when you have a rational equation, it's an equation with lots of ratios. The simplest way to deal with it is to multiply throughout by the lowest common denominator. That way, all the denominators will cancel and get a polynomial which you can solve. For example, 1 over a equals 1/3 minus 1 over 3a. And these have denominators a, 3, and 3a. So the lowest common denominator is 3a. So we'll multiply throughout by 3a. We get 3a over a equals 3a over 3 minus 2 times 3a over 3a. Okay, a's cancel here, 3's cancel here, 3a's cancel here. We're left with 3 equals a minus 2. Add 2 to both sides. 3 plus 2 equals a. So a equals 5 solves the equation. All right. Here we have 18 over y plus 1 plus 2/5 equals 4. Here the lowest common denominator is 5 times y plus 1. So you multiply 18 times 5y plus 1 over y plus 1 plus 2 times 5y plus 1 over 5 equals 4 times 5y plus 1. Y plus 1's cancel here, the 5's cancel here. We're left with 90 plus 2y plus 2 equals 20y plus 20. And after the usual bit of shuffling, the algebraically shuffling things around, we get y equals 4, and there's a solution. You have p minus 1 over 2 plus 1 equals 3 over p. Denominators are 2 and p, so multiply throughout by 2p. So p minus 1 times 2p over 2 plus 1 times 2p equals 3 times 2p over p. 2's cancel here, p's cancel here, and multiply it out. P squared minus p plus 2p equals 6. Okay, combine these terms, transpose, subtract 6. P squared plus p minus 6 equals 0. And okay, this factors the two numbers which sum to 1 and multiply to -3, and plus 3 and minus 2 due to the trick. So this is p plus 3 times p minus 2 equals 0. And since one of these factors must be 0, either this is 0, so p is -3, or this is 0, so p is 2. So 2 and -3 are the solutions to this. Okay, now there's sometimes there's a problem, what are called extraneous roots. For example, the problem is that it's not considered good form to divide by 0. So if one of these, if you get a solution where one of these denominators is 0, we have to rule that out. We call it extraneous. So okay, here 3 over r plus 12 over r squared minus 4r equals -7 over r minus 4. Okay, the thing to do is factor this r squared minus 4r into r times r minus 4. Now here, r equals 0 would cause a division by 0, and r equals 4 would cause a division by 0, so we rule out those values for r from the beginning. Now, all right, denominator is r minus 4, r times r minus 4, so the lowest common denominator is r times r minus 4. And you multiply throughout, there, there, and there. R is canceled here, r minus 4 cancels here, r minus 4 cancels here. So we'll get 3 times r minus 4 plus 12 equals -7r. Okay. A fairly simple linear equation, distribute the 3. 3r minus 12 plus 12 equals -7r. Move the 7r to the right, move the 12 minus 12 to the left, and to the right, okay. So you get 10r equals 0. So r must be 0, but this is one of the solutions that was ruled out. Plug in r equals 0, get 3 over 0 plus 12 over 0 equals negative 7 over negative 4. I'd be saying infinity plus infinity is negative 7/4. Well, in a sense, that's right. Infinity plus infinity is actually indefinite, so it can equal anything. But still, that sits badly. So we say that this has the solution r equals 0 is what's called extraneous. So really, this doesn't have any solutions. So with these, so the difficulty is that this process of multiplying by r times r minus 4 created a root which didn't exist before. So therefore, when we solve one of these rational equations, we really are obliged to test any root found to see that they're not ruled out from the beginning as a division by 0. We'll run into the same thing when we get to radical equations. So we'll have to substitute back in to test if we're not getting more extraneous or spurious roots. I don't know why it's being so slow today. All right. You have x minus 4 over x minus 3 minus x minus 2 over 3 minus x equals x minus 3. Now these are subtractions in opposite order, x minus 3 and 3 minus x. We can fix that though. We'll flip this 3 minus x to an x minus 3 and change the minus to a plus, and then we'd be fine. Okay, well, the denominator is x minus 3, so we multiply through by that. We get x plus 4 plus x minus 2 equals x minus 3 times x minus 3. Oh, by the way, up here, since we're dividing by x minus 3, we have to rule out 3 because that would be giving you a spurious solution. So, all right, here we get this. This is 2x minus 6. This extends out to x squared minus 6x plus 9. Transpose the 2x, minus 6 minus 2 is a minus 8x. 9 plus a 6 is 15, so 0 equals x squared minus 8x plus 15. We need two numbers which sum to negative 8, multiply to 15, and negative 3 and negative 5 do the job. So 0 equals x minus 3 times x minus 5. And then, well, so either this is 0, so x is 3, or this is 0 and x is 5. Again, we need to check, and if we do that, we'll get infinities on the left and 0 on the right, and that's not really looking good, so we rule that out. We throw in 5, however. 5 here, 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 and here. 5 minus 4 over 5 minus 3 minus 5 minus 2 over 3 minus 5. That's a half minus negative 3 halves, which is 2. The right is 5 minus 3, which is 2. They fit. So 5 is a solution. 3 was not. So that's the one solution. I don't think it's not yet. It's getting slower. I don't like this. All right. Here we have negative 10 over t plus 3 equals 1 minus 11 over t minus 3. So t can't be negative 3, and it can't be positive 3, because then we'd be dividing by 0. We multiply throughout by their product. Negative 10 t plus 3 t minus 3 over t plus 3 equals 1 times t minus 3 t plus 3 t minus 3 minus 11 t plus 3 t minus 3 over t minus 3. T plus 3's cancel here, t minus 3's cancel here, negative 10 t minus 3, 11 t plus 3. Sum times difference is a difference of squares, t squared minus 9. Okay, expand this out. Negative 10t plus 30 equals t squared minus 9. Multiply this out. Minus 11t minus 33. Add 10t and subtract 30 from both sides. 0 equals t squared minus 9 minus 11t minus 33 plus 10t minus 30. All right, then we combine like terms. Here's a t squared minus 11t plus 10t is minus t. Minus 9 minus 33 minus 30 is a minus 72. 0 equals t squared minus t minus 72. We need two numbers which add to negative 1 and multiply to negative 72. After a bit of searching, you get 8 and negative 9. So 0 equals t plus 8 times t minus 9. One of these factors must be 0. So here gets you t equals negative 8. This gets you t equals 9. Neither of these are ruled out over here. So these both check out. These are both solutions. Very strange. All right. 3 over s minus 2 plus, this is an s now, so 5. S minus 14 over 2s squared minus 3s minus 2 minus 4 over 2s plus 1 equals 0. Now, all right, going through the AC method, which I won't bother showing you here, this factors into 2s plus 1 times s minus 2, which is here and here. Now, all right, because we don't want s minus 2 to be 0, s can't be 0, s can't be 2, and we don't want 2s plus 1 to be 0, so s can't be negative 1. So we rule these out as solutions beforehand. All right, to get rid of all these denominators, we multiply by 2s minus 1, s minus 2. So 3, 2s plus 1, 2s minus 2 over s minus 2. These will cancel. Plus s minus 14 times 2s plus 1, s minus 2 over the exact same. So these will cancel out. That minus 4 times 2s plus 1, s minus 2 over 2s plus 1. The 2s plus 1s cancel. So we're left with 3 times 2s plus 1 plus s minus 14 minus 4 times s minus 2 equals 0. All right, you expand it out. Here, 6s plus 3 plus s minus 14 minus 4s plus 8. Watch out, minus and negative is plus. Equals 0. Combine like terms. 3s minus 3 equals 0. 3s is 3. S is 1. And since it's neither of these, so this is the one and only valid solution. Ah, 11a and b, 89a and b. 89 asks to simplify this expression, and 89b asks to solve this equation. All right. 11 12 minus 3 over 2x plus 4 over x. 12, 2x, and x, well, least common multiple has to have an x. Has to have a multiple of 12, 2 and 12. 12 will do. So 12x is the least common denominator. So 11 over 12 is 11 times x over 12x. 2x goes into 12x 6 times, so we have minus 3 times 6. X goes into 12x 12 times, so this becomes 4 times 12 over 12x. So 11x minus 3 times 6 minus 4 times 12. It's 11x minus 18 plus 48 over 12x. And that's 11x plus 30 over 12x. Okay, so that simplifies this expression. As for solving this equation, well, similar thing. Well, first of all, it's an equation, and it's a rational equation. So we want to rule out making any of the denominators 0. So x can't be 0. As before, the least common denominator is 12x. So we multiply throughout. 12x times 11 twelfths minus 3 times 12x over 2x equals 4 times 12x over x. 12's cancel here. Well, 12 against 2, 12 against 2x leaves us 6 here. X's cancel. So this will be 11x. This will be minus. This turns out to be 3 times 6, so it's minus 18. Here the x's cancel. 4 times 12 is 48. 11x minus 48 equals 11x minus 18 equals 48. Add 18 to both sides. 11x equals 48 plus 18. Combined terms. 11x equals 66. Divide throughout by 11. X equals 66 over 11. X equals 6. And since that wasn't ruled out at the beginning, this is our solution. Okay, one last page, and I hope it pops up in good time. Ooh. I don't know what's going on here. I mean, when I was in the before times, when I was doing everything by a blackboard by analog methods, I mean, occasionally the marker would run out of ink, but it wouldn't stop and stop for a minute or so. I'm not sure what's going on here. But there we go. Come on, you can do it, machine. You can do it. You can do it. Yes, you did it. All right. 1 over f equals 1 over s1 plus 1 over s2. This has to do with focal lengths of compound lenses. So you have a lens with focal length of s1 and another with focal length of s2. Put them next to each other and you get a combined lens with a focal length with this equation. So first question is, what is f in terms of the s's? And given that s1 is 5 inches and s2 is 60 inches, then what is f? All right, here, 1 over f equals 1 over s1 plus 1 over s2. We use what I call the rabbit rule for adding this. 1 times s2 is s2 plus s2 times 1 is s1 over the product. s1, s2, that's f, 1 over f. 1 over f equals a sum over the product. Then we flip both fractions upside down. And the f is on the left equals, and this becomes the product over the sum. F equals s1, s2 over s2 plus s1. This operation of product over sum is something I call reduction, and there's an extra credit set covering it in the extra credit module. Okay, now if s is 5, 1 is 5, and s2 is 60, what's f? Well, here we go. F equals the product 5 times 60 over the sum 5 plus 60. That's 300 over 65. Here the units are inch squared. Here the units are inches. They cancel to inches. 300 over 65 inches, which is the same thing as 60 30ths of an inch, or 4 and 18 30ths of an inch. Okay. I don't know why it's taking so long to respond to everything. Okay. Stop recording. Recording is stopped.